Righty, so is everybody ready to go then? Should we get started? So I'm Phoebe, I'm from the University of Wolverhampton and I'm part of the STEM response team. And we are getting involved in the Dig It Up project as part of the Making the Difference project with the Royal Society of Chemistry and the University of Oxford. So I'm going to pass over to Elise now just to get us really introduced into this Q&A session and tell us what the project is all about.
Thanks, Phoebe. So hi everyone, my name is Elise. Just before we do get started, I just want to make everyone aware that this is a live recording of the Zoom session. So whatever you say on, well, you're not going to actually be speaking, but whatever you put in the question box or the comment box, it is live. So please don't share any personal information or anything that you can, like any contact information, as it will be going live on YouTube after this session as well. So if you do have any questions, please try and pop them in the Q&A box down below. So if you just go move your mouse to the bottom of the screen, you'll see the toolbar pop up and you have the Q&A bar and the chat bar. Try and put the questions in the Q&A bar as we can see these better than the chat boxes, okay? And you can do that at any point you want to, and we'll try our best and answer all your queries. So I'm just going to kick things off by discussing our project and what the Dig It Up project is all about. So as a collective, myself, Phoebe, Heather, and the other amazing women involved, such as Nazira and Sharon, we've all made this project called Dig It Up as part of the Making the Difference collaboration. And what the project does is it's going to kind of give you an introduction to environmental sciences and importantly to green chemistry, as we're taking a different approach and we're showing you how chemistry can also benefit the environment and sustainability. So our project, Dig It Up, focuses on one problem in particular, and that problem is plastics. Now, in this project, you're going to explore the differences between certain plastics and the differences between recycling and what biodegradable means and what compostable means. And you're going to do this by investigating your own biodegradable and compostable bags you might get from supermarkets. So on the website, if you've already looked, we have an equipment list and a method list. In these sections, you can find out all the things you need to take part in this project and a list of where you can get the equipment from. In this case, where you can get different bags from and how much they cost. So for example, we have a whole range of biodegradable bags from supermarkets like Aldi and Asda. And then we have some compostable bags such as Morrison's. So you can really choose which ones you want for this project and whatever is suitable due to your location and your budget as well. So we hope this project is inclusive for everyone. So what we're going to do in this project, starting from today or whenever you can, is you're going to collect your bags. We're going to try and make sure that one bag is compostable and at least one bag is biodegradable. That way we have a good selection and we can compare the two between each other. So you have at least one compostable, at least one biodegradable. And what we're going to do, we're going to dig them down into the earth if you have a garden. If not, we're going to use plant pots. And we're going to see how the degradation process actually works and how fast it works. By using different bags, so compostable, recyclable and biodegradable, we're then going to compare which one degrades faster and why that might be. And from doing this, you can then use these choices in your further life if you want to be more environmentally friendly and if you really want to know if things like biodegradable or compostable actually work. So we hope you have a great time doing this project. We've really thought hard about how we can include you guys into making a sustainable choice by using green chemistry. And we've also related it to the amazing green chemistry that we do at the University of Wolverhampton by making our amazing biopolymer materials that actually can act as a replacement for these plastic items. So all our research as well as the methods and the equipment are on the Making It Different website. So please take the time to have a look. And if you do have any more questions regarding the research, that's what you can ask our amazing audience here today, such as Nazira, Sharon and Heather. So I'll pass over to Heather now, who will go on to introducing our amazing women in chemistry.
Thank you, Elise.
So as Elisa's mentioned, we're joined here today by some amazing chemists that work at the University of Wolverhampton. First, we have Professor Nazira Karodia, who is the Provost Chancellor for Regional Engagement. And we also have Dr. Sharon Moore, who is a Senior Lecturer in Analytical Chemistry. So if you'd both like to introduce yourselves just a little bit further and tell the audience who are watching today just a little bit more about yourselves and your interest in chemistry. Nazira, if you'd like to go first.
Good afternoon, everybody. As you've heard, I'm Nazira Karodia. I'm the Pro-Vice Chancellor for Regional Engagement at the University of Wolverhampton. And I always say that I'm a chemist first. So my research is in green chemistry, looking at catalysts and looking at some different ways in which you can make new bonds between carbon atoms. So I've been a chemist for a couple of decades, and I won't say when I started being a chemist. I think I've always felt experimenting and trialing new things. It's what excites me about chemistry. So I do hope you will enjoy all these resources. I should also say there is a network for chemists, oh no, not chemists, but Kids Against Plastics, which has a lot of resources, and I'll put that link onto the chat as well.
Fabulous, thank you so much, Nazira. We'll pass over to Sharon now. Sorry, Sharon, carry on.
Hi there, I'm Sharon Moore. So like Nazira, I've been doing chemistry for an awful long time, a couple of decades or more. And my interest nowadays is more in sort of bioanalysis, so analysis of sort of biological fluids, and in particular DNA adducts and the link to cancer, and how we can utilize that information with predicting disease and diagnosing disease and so on. So quite a different area of research to Nazira. And I've been at Wolverhampton for about 4 years now, so a reasonable amount of time, and taught elsewhere as well. And a little bit of interest in the plastic pollutants as well. So we've had some research going in that area with undergraduate students looking at that in the past. So there's a broad range of interest, basically anything that you can analyse. I've probably analysed it at some point.
Okie dokie. Was that everything? Sharon, is that everything? Sorry.
Yep, over to you guys.
Fabulous, thank you so much. So yeah, if you wave your little cursor about on your screen, this is for the attendees, not the panelists. So if you wiggle around your cursor on the screen a little bit, you can see the Q&A section below. So if you have any questions for any of us, so that can be me, Heather, Elise, Dr. Karodia or Dr. Moore, please feel free to pop the questions into the Q&A section and we will do our very best to answer them. So I'll be the one taking a look at the questions and announcing those to the panelists. So fire away any questions you might have about chemistry, being a woman in science, in chemistry, anything like that. Not really sure what to discuss in the meantime. Does anybody have any ideas?
So I have a question that we can all discuss collectively, which might be of some help for those in the audience. So obviously chemistry is quite a specific topic if you think about it, but chemistry is around us in the whole world. A lot of things that we do don't even encompass, we don't think encompass, I can't say the word, encompass chemistry is what I'm trying to say. So a lot of us have research that might actually not actually be chemistry focused as specifically like a master's degree or a BSc in chemistry, but what we do does encompass chemistry in some other form or not. So I myself can discuss how chemistry is in my field, such as animal behavior, which is kind of a field where you wouldn't expect chemistry to be. I'm happy to talk about what I've done with my research involving chemistry and the chemical communication of primates. But is there anyone else first that would like to say how their field supports chemistry in an indirect way, if that makes sense? Yeah, I don't mind going first. So my background is in forensic science, and chemistry is throughout forensic science, no matter kind of what area you're specifically looking at, it's all in the subdisciplines. So there's some obvious things that incorporate chemistry within forensic science, such as forensic toxicology. So that's looking at different kind of chemicals and doing chemical analysis on this, but it's also doing chemical analysis on blood work and also looking at the blood alcohol levels and all things such as that. But there's another area of aspect that incorporates chemistry in forensic science, and that is looking at the post-mortem interval, which is how long someone has been dead. So my research here at the University of Wolverhampton is researching into the post-mortem interval and looking at what indicators we can analyse to help pinpoint how long someone has been dead, and this can be useful in investigations. So the way chemistry is involved in this is looking at volatile organic compounds. So these are essentially the smells that are created by something that is decomposing, not just a person or an animal, but this is also the same for any kind of organic material, such as like plants and flowers also. So simply, it is looking at the profile that is produced by something that is decomposing and looking at that profile exactly to see if we can pinpoint any almost abnormalities, so things that are quite different, and whether these change over a period of time. So these can be used to help determine how long a person or object has been there decomposing, and then this hopefully can be useful in investigations in the future.
So how did you come to decide to do that particular research, Heather? I was quite interested when I first heard about the volatile material that you talked about. Do you want to explain a little bit more? Because I think some of that links to maybe the analytical chemistry that Sharon does. So could you just explain a little bit more?
Yeah, of course. So the area of forensic toponymy, which is what all this kind of falls into in forensic science, it simply looks at all the changes that occur to something after it's died and how we can essentially analyse that and quantify that and basically be able to put it in some kind of order so we can use it for further investigations in kind of police analysis and police investigations. So in terms of volatile organic compounds, no matter anything that decomposes, as I said previously, it produces this smell, and this smell is produced by every living object that is on this earth, as Elise will discuss a bit later on in terms of animal behaviour. So we know that when something decomposes, they produce these gases due to the biological kind of breaking down that happens in your body. So when you die, your cells and the bacteria kind of start breaking down each other to break down all your proteins and all your tissues and all the organs that are inside your body. So then essentially you become almost compost for the earth. So as it's doing this, it releases a lot of chemicals in your bodies that normally are produced through gases. And this is what we analyse. So when somebody dies, we take a sample of that air and we run and look at this and look at its profile. So we see different kind of chemicals and elements that are present. And we run this through a kind of analysis called gas chromatography. And through this, we're able to see the different kinds of chemicals that are present and the amount of these chemicals that are present. But the key importance here in the post-mortem interval, which is how long someone's been dead, is to look at the changes in this profile itself. So I want to investigate really whether the profile of the gases that are produced over however long it takes for a skeleton to be produced are the same throughout, or whether there are unique chemicals and gases which are produced at specific points during the decay that we're able to use to identify how long this person has been there. And this is a really important topic and area of kind of research, as it's useful for police investigations, as they may come across an unidentified person and want to help identify this person and help kind of piece together their story of how they got there, how long they've got there. But most importantly, it'll help bring kind of a sense of comfort to families in the future to be able to identify who that person is and identify how long they've been there and kind of bring them a bit more comfort and piece together that story of that person. So it's a real interesting subject area to study, and it's something that we don't know exactly what will happen at the moment with the research. So I'll be sure to tell you more once I know.
Fabulous. Thank you so much, Heather. And I think we do have some questions. So we've got one here, which was the first one. And this question is from an anonymous attendee, and it says, where can you get a biodegradable plastic bag from? So I think Elise can answer this best.
Yeah, I'll take this one. So we have got a whole list of bags and where to get them from on the website. And what I'll do, I'll just copy that information and paste it into the chat in a moment. So biodegradable bags, although they're amazing things, a lot of supermarkets have bags for life rather than the single-use ones that you want to compost or throw away. But you can get biodegradable bags from Aldi, and I will pop them in your answer right now, along with some other supermarkets that do contain compostable bags too, and with all their prices on. So you can get compostable bags from Morrison's, Co-op. Any kind of paper bag will also be compostable. But like I said, you can get the biodegradable ones from Aldi, and they are made of a substance called bioplast, and they are 6p per bag. They're quite thin and they look green, and they're by the tills if you go there.
I think I had one from my Aldi shop back on Saturday. So the next question, which we're going to answer live, is do plastic bags give off the volatile organic compounds when they decompose like a body? This got quite grim, so I'm not sure who would best answer that. Maybe Heather, but we'll open it up to all panelists, so fire away.
I think that's quite an interesting question, and from my knowledge itself, I honestly am not afraid to admit I have no idea. That is quite an interesting. You'd think as something decomposes, it possibly may produce volatile organic compounds, which can be measured, I suppose. Does any other panelists have a bit more information on this?
I don't know anything specifically about plastic bags, but it's going to depend on the nature of the material that bags are made of and what compounds they break down into. So as an analytical chemist, we analyse things by gas chromatography, as Heather said, or we might analyse things by liquid chromatography, which would be the non-volatile compounds. So it very much depends on the knowledge of what those specific compounds are, whether they're volatile or non-volatile. So off the top of my head, I can't say, but yeah, there is the potential to be able to measure them.
Just to add in on what Sharon said, sorry. So when we're talking about plastic bags, obviously there's quite a lot of plastics that we use in the world, but plastic isn't just plastic. There's a whole lot more to plastics than we think when it meets the eye. So if you do go onto the Making Difference website and you do go onto our research and our methodology sections, what's on there is a nice big diagram of the different types of plastics that are available at the moment in the world. So these have like little codes on them, and they're called different names. So if you get these plastics, some will release more volatile organic compounds than others. So it's up to you, up to the plastic, sorry. So more of one type will do more than the other type is what I'm trying to say. So it would be a really good idea if you want to go ahead and research this more for anyone in the audience as like a kind of add-on or like a challenge to the project to kind of see which type of plastics are in a way worse for the environment with the amount of volatile compounds they do leach out. That would be a really interesting take on this project as a challenge to be extra.
Fantastic. Does Nazira have anything to add?
I just wanted to say that there are a few plastics that are composted, but they are, in general, compostable plastics are more expensive to manufacture. And in fact, some plastics take over 1,000 years before they will decompose in the landfill. And when they do decompose, then they break down into some chemical components which are very toxic to the environment. But of course, I think we've heard about the microplastics. So they break down into tiny, tiny pieces of plastic, very small particles, which I think we all might have inside us because we've been eating them, you know, in breads and goodness knows what. I do not want to worry anybody about eating stuff, but we are consuming microplastics on a daily basis.
All right, thank you so much, Nazira. So The next question we've got is, what sort of things do you do on a day-to-day basis as a chemist? So I think Sharon and Nazira will be best to answer those questions. So I'll let you fight amongst yourselves as to who will answer that one first.
I think Sharon's the more active chemist than I am. So Sharon, you go first.
Yeah. Okay, so I will answer that. I mean, at the moment, because I'm a lecturer, I do predominantly do teaching, but I do get periods of the year when I manage to get into the lab and do some research. So I'm an analytical chemist, so I would basically be preparing samples, which that would mean doing a range of different processes dependent on the sample. So I said I do mostly bioanalysis, so that would involve breaking down the samples in some way. It might mean heating them, it might be treating them with acid, it might be filtering them and so on, in order to get the sample into a format that we can actually analyse. So that means that we either have to be able to get it into a volatile state if we want to do gas chromatography, or into a liquid solution with no particulate matter in there in order to analyse liquids. Making up solutions, using instrumentation such as mass spectrometry, doing quite a lot of data analysis, a lot of data processing. So I'm an analytical chemist, so I very much spend my time preparing a lot of solutions and a lot of instrumentation type of stuff. Other scientists are more kind of synthesis based, so they would be at the bench mixing things together, having reactions, isolating products, and then analysing those products at the end to make sure that they've got the compounds that they want. I have worked in industry in the past. I've worked in quality control labs. Very early on, I studied part-time for a degree whilst working in chemistry labs. So I have worked full-time in industrial labs. You can end up I worked in a soils analysis lab, and we used to go out and take soil samples. I used to have to go into a soils basically storage area and grind up soil samples for analysis. So it very much depends on the area that you're working. It can involve a huge range of different types of jobs. And you certainly don't expect to see a chemist perhaps out in the field with a pair of safety boots and a helmet on and up high ladders and so on. I think the sort of things that I used to do. It can be very varied.
That's wonderful. Thank you so much.
So Sharon, I think you've had a more exciting life as a chemist, climbing up ladders. So as a chemist working in a university, then most of our life, I think, is in labs in a university. And my chemistry is very much about making sure that I can find the best method of connecting or making bonds between carbon atoms. And this is not just random, randomly, but in a very clean way, in a very green way. So looking at effective processes, so it reduces waste, uses fewer steps, less energy. And so there's quite a lot of trial and error. There's a lot of analytical chemistry involved as well, where I have to analyze the structure of the molecule I have made. And that's the exciting part of being a chemist in a research lab. I should also add that all chemistry degrees at university have big components of research experience. And so when you get to your third year or fourth year, depending on the kind of degree you're doing, you get a chance to experience different types of chemistry where you are directing and designing the research you want to do. And I was most excited when I was in my undergraduate years around organic chemistry. Now, these little phrases, analytical chemist or organic chemist, they just neat ways to classify what the chemist does. So an organic chemist works mainly in making molecules made from carbon. And so that's the kind of research that excited me when I was an undergraduate and made me want to carry on to look at more research in that way. It was only later on when I realized I was using such a lot of solvents to make some of these molecules. And this is quite expensive. Solvents are quite expensive as well, because not only do you use them for your experiments, but then you've got to dispose of them and you've got to pay for that disposal as well. That's when I decided as a research chemist to look at alternative ways of making these molecules, because the relevance of this is that these organic molecules, they are what are used in the pharmaceutical industry, so for making medicines. And in fact, the pharmaceutical industry is one of the ungreenest. Is that a word, ungreen? Non-green, non-sustainable, non-sustainable if we look at the amounts of solvents that are used and the amount of processes and steps in place to just make, a small amount of material at the end. And so there's a lot of improvements now in industry where specific steps in a chemical reaction might be improved, if not the whole process being improved all at the same time. So we want to move towards that kind of step. Some of the solvents that have been used have also then been applied to other fields. So while they've been designed to improve a particular chemical process, they've then been discovered to have other properties. And so that's the beauty about research. Once you make a new material, you then test it and you find that it has other applications. So some of the molecules I've made have found applications not only as an alternative solvent, but when I tested how safe they were to use, I found that actually they did kill some fungi and some bacteria. So that leads me to a different field of research. And so the research career and what we do day to day in a university lab can be quite different sometimes to what happens in industry. You can, in industry, you have a particular task, a particular job, and sometimes there might not be that opportunity to go on a different sub-project, because actually you won't develop your medicine or your drug or your plastic, your green plastic, if you just, explore different ways at different opportunities. So it is quite exciting to have that balance of being really focused to develop something new, but then that has a practical application, but also at some points to have that ability to explore different avenues when an opportunity comes up.
Thank you so much. And if anybody who wants to learn more about Nazira's wonderful research, I've just popped in the chat now the Meet the Team section on the website. So if you just pop onto that link there, dig it up, Meet the Team, you can click on Nazira's tab, and under that tab there is a wonderful presentation made by her, voiced by yours truly, all about Nazira's wonderful research in green chemistry. So if you want to learn a little bit more about that, just pop on the website. So another question that we have in the Q&A tab is, how are plastics made? So who wants to take that one?
I know a lot about plastics, but unfortunately I'm not too sure on the whole chemistry of what goes into them and how the polymers are actually made. So I'm not sure if Nazira or Sharon knows anything more about this certain question. If not, it's something that we can go away and find out and relay the information to you either on the website or at a later date. But beforehand, does anyone else want to answer this question?
So there are lots of different ways of making plastic. And oh, Sharon, sorry, you wanted to come in first.
No, it's fine.
Okay, I'll just kick off and then Sharon can join in. I was just going to say, the term plastic includes lots of different types of material and have various elements in them, such as, carbon, hydrogen, oxygen, nitrogen, chlorine, which is, one of the elements we say is not so good for the environment. And the main thing about plastics is that they have a very high molecular weight, meaning that each molecule can have, millions and thousands of atoms joined together. And so plastics are made from smaller materials, all joined up to make one big molecule, which then bonded together gives you and processed to be able to give you the plastics that you have at home. And plastics can also be called polymers. That's why we say polymer, because poly means many, and they are made from monomers. So monomer meaning a single, smaller starting materials. And the chemicals that are used to make plastics can come from many materials. Normally, they come from natural gas, from coal, so sort of that petroleum background. And these are very cheap, you can imagine, because there's a lot of petroleum products and lots of starting materials we can get from there. So they're very cheap. And that's why plastics, the one that you can't decompose, are so cheap as well, because they're easily sourced out, and they're easily to be synthesized, and they can be easily melted and reformed into different and molded into different things.
That's wonderful. Sharon, did you have anything to add to that?
Now, I was only going to add that we do have people that are polymer chemists working within the chemistry department. And basically it is polymer chemistry mostly, but yeah, we're no experts in this at the moment.
Yeah, thank you for that, Sharon. Unfortunately, our biopolymer chemist couldn't be here today. So I will read out another question. So we've got, what is the difference between biodegradable and compostable, please? How very polite. So whoever wants to take on that question, feel free, fire away.
I'm happy to take this one, that's fine. So the terms biodegradable and compostable, they often get mixed up from time to time and kind of lumped as, it's the same kind of thing, but they are different. So when we're talking about compostable materials, these are materials that are made from just plant matter. So for example, a compostable bag, such as paper, it's made from wood, a wood pulp. That is all made from plant matter, and when it goes into the ground, it degrades via natural processes. So nothing like human induced is needed for it to degrade. So in terms of things like paper, what happens, it degrades over time in soil due to water and weather conditions, and in the degradation process, eventually after a few years, it does turn into carbon dioxide, so CO2, water, H2O, and this material that we know as biomass. And biomass is just organic material left as a waste product, such as soil and like compost. So biodegradable is a bit similar, but this is where we can get mixed up a bit. So when we talk about biodegradable, sometimes biodegradable can be compostable. The two can kind of be the same, and sometimes it can't. So I'll explain that in a bit more detail, as you're probably already confused right now. So if an item is biodegradable, but it's made from biodegradable plastics, this means that the plastic it's made from can degrade due to small microorganisms, such as like decomposers, like bugs. They can eat it, and they can help in the decomposition process. But the only problem is that if the plastic, made from plastic polymers, not organic polymers, if it's plastic, it can't be degraded completely 100%. It can be degraded into smaller pieces, and these are what we know as microplastics. So you may have heard Nazira talk about microplastics earlier, and if you watch David Attenborough, there's a lot of talk about microplastics on there as well. So what microplastics are, they're just very, very small pieces of plastics that have degraded from a larger piece of plastic, and these stay in the environment for thousands of years, and these are the things that cause catastrophic environmental destruction in the terms of like animals can eat them, they can pollute our water systems, and research even shows that now we are eating plastics as well, and plastics are inside our bodies. So that's what happens with biodegradable plastics. So they degrade into smaller pieces but not completely disappear. Now, biodegradable things that are made from plant material degrade completely. And the word biodegradable just means that the degradation process is helped by microorganisms, if that makes sense. So not all biodegradable materials are compostable, but some are.
Fantastic. Thank you so much, Elise, for that clarification. So for now, we just have one more question. Oh, another one's just popped in. So we've got, I just want to be mindful of the time. We do have just under 20 minutes left because the session does have to end quite abruptly. So we've got 2 more questions. So what chemicals do plastics give off that are bad for the environment?
So I'm happy to start this one again, and as I go on, if any other people have any contributions, feel free to say those in the chat. So obviously, starting off again, I am not 100% a plastic chemist or anything. My expertise is in the environment, so I do know a bit in terms of this, but not completely. So if anyone has any other contributions, please say so. But in terms of chemicals that are leached from plastics into the environment, there are a few that come to mind just to start with. One of the main ones that you might have already heard of is something called BPA. And these BPAs are, they're kind of like molecules that are leached into the environment. And these are highly toxic. These are the kind of molecules that are known to disrupt hormones in both animals and humans. So a lot of them mimic the hormone estrogen. So the fertility hormone, so to speak. So a lot of BPAs have been linked to things like an increase of breast cancer, especially in humans, and even in fish populations it has been seen to increase sexual maturity faster. So in humans we talk about like the age you reach puberty, that has become younger and younger, and many people think it might be because of these BPAs. And in extreme cases, some scientists also link BPAs to infertility. Another thing that we may have heard of is called PVC. So these are polyvinyl chlorides. And again, these are like one of the most toxic things that can come out of plastics. Again, and these can leach into our own bodies too. So there's quite a few toxins in plastics that do leach out into the environment and then therefore go into our water sources, into our food sources, and into us as well. And the main disruptors are hormonal. So if anyone else has any specific examples for that, maybe they can help you, but those are just some of the few broad examples that I've got.
Fabulous, thank you. Do any of our other chemists have anything to add? You can give me a big old head shake if no. Okay, so that's a no from Sharon. Okay, so it looks like for now we have one more question, and that is, how can we get rid of the plastics in our bodies? Oh, that's a point of contention there, I can see. So does anybody have any answer to that at all? I'd like to pass that on to the rest of the crowd.
So one way we can get rid of plastics in our bodies is obviously, it's a bit of a morbid one, but through the food chain, I guess. So obviously other animals, they get plastics in their bodies and then we eat the animals, and that's how we get the majority of plastics in our bodies. Obviously we excrete a lot of waste, which then passes that plastic along back into the environment like in a big cycle. But as to getting rid of the plastic that's already in our bodies, that's one of the major concerns as to why we need to, really start to reduce our plastic consumption. Experts kind of estimate that at the moment we're eating a credit card worth of plastic. I think it's every week or every month. I hope it's every month rather than every week. So yeah, and the most food. So rather than focus on how to get rid of the plastic in our bodies, which seems like an almost impossible task, we can try and focus on how to reduce the amount of plastics that we are ingesting. So yeah, opting for, rather than taking like a plastic drinks bottle, like you go to the shop and buy a water bottle that may have BPA's in there, just get like a stainless steel water bottle. That way you're not, you know, contaminating your water with plastics. But also to be mindful of what you eat as well. So obviously microplastics, as we said, are a huge concern. Most of these microplastics do end up in waters, and then the fish eat all the microplastics. So the more fish and seafood that people eat, unfortunately, the more microplastics that get passed through the food chain into our bodies too. I know it's quite a scary thought, but like even mothers now that have unborn babies, so in the womb, even microplastics can make their way through blood to the new baby. So it's really like, what can we do to reduce this in the future is what we should be thinking about, I think. I'm not sure if anyone else has any thoughts about that.
Not really, at least. It's, as you were saying, it's everywhere. It's you know, in all the water supply, it's on the beaches, and it's ingested by marine animals, and then comes further along the food chain. We know some of the I should say harvesting of marine life is then made into animal food, so it then passes into, you know, land-based animals, if you like, and then down the food chain as well. So it is quite challenging to be able to think how you're going to get rid of it completely, just because we've depended on plastics for such a long time, and have not really thought about the end life of a product. We've just thought about the use of it, because it's made life so convenient for us. It's changed a lot of our behavior, and now we are trying to retro fix this. But what we can do, as Elise was saying, is minimize any further damage to the environment by changing our behavior, like, you know, using compostable plastics and so on.
Fabulous, thank you so much. Yeah, I agree that plastics are a wonderful material. They're an amazing invention, but unfortunately the way it's disposed of, and as Nazira just stated, the end stage of plastic use maybe wasn't considered as much as it should have been. So now we've got to start doing what we're looking at now, which is green chemistry, biodegradable plastics, and moving forward with our use of plastics, rather than getting rid of it entirely, saying, okay, what can chemistry do to help us? So let's take a look at the Q&A. So we've got two other questions. Let me just check the time. We're doing fine. So is it true that there are bacteria that can eat plastic bottles? That's a really interesting question. So does anybody want to introduce that concept?
So there are bacteria that can chew their way through plastic and make it less harmful. And that's led to the research and a lot of developments around the biodegradable side of it, rather than heating or burning or a chemical breakdown of plastics in that way. So yes, these bugs, as I like to call them, you know, can be brought into an industrial scale where they can be used to eat their way through the plastic. So the hope is that those big islands of plastic that have accumulated in the ocean can be treated in some way by these bacteria eating, no, not bacteria eating, by the bacteria eating the plastics.
Okie dokie, thank you so much. And as we said earlier, in the chat, there's a link to the research part of the Making the Difference website. And if you pop on there, you can have a look at a lab tour at the University of Wolverhampton, where one of our wonderful women in chemistry, Dr. Isabella Radecka, tells us all about the research, where part of it is about bacteria consuming plastics, reuse of plastics, that sort of stuff. So do take a look at the website if you want to learn more as well. So we've got a couple more questions. I think we're going to have to start doing a bit of a Speedy Gonzalez going through these questions. So is having plastic in our body harmful?
I don't mind starting this one. So at the moment, with the amount of plastics that we do have in our body, I mean, as I said, a credit card a week or a month, it does sound a lot, but when it's in our body, it's, well, as you ask yourself, like, have you noticed any plastics causing a problem in your body at the moment? The answer is probably and hopefully no. So there's no cause for concern right at this moment in time. But again, if we look to the natural world and use other animal examples to kind of predict our own future, we can see some problems that start arising. For example, if we look at seabirds, seabirds are unfortunately one of the major casualties of the plastic problem, especially microplastics. So as they dive into the ocean to get food, such as fish, they unfortunately pick up lots of plastics too. Now, due to their size, obviously they have quite small stomachs. This was on an episode of Attenborough, I think, Perfect Planet in the sea one. So if you're interested, David Attenborough, Perfect Planet Ocean episode, it explains this in detail. So as they eat more and more plastics, obviously the plastic has nowhere to go. They can't digest it. It just sits in their stomachs. And eventually, over time, so over a few years, the plastics fill up in their stomachs to the point where, one, they get too heavy to actually do anything useful like fly. Birds have to keep eating time and time again to get their energy up. And if their stomachs are full of plastic, they can eat less and less actual nutritious food. So a lot of their space in the stomach is used by non-nutritious rubbish, so to speak. So it really hurts the amount of food they can actually eat. And eventually they will unfortunately die as a result of this plastic consumption in their stomachs due to not having the food to eat, the room to eat normal food, and to it obstructing airways and whatnot. So that's quite an extreme example in the animal kingdom. We can also see that with like whales and tortoises and turtles when they get blockages from eating plastics and their stomachs fill up full of plastics. But that's more of like the large items such as like pen lids and plastic bags, which fortunately we're a bit smarter and we don't go around eating those. So there is the potential, I mean, talking further down the line, like quite a few substantial years and decades for plastics to be a problem. The main problem, really, we don't really know yet because it hasn't happened. So we might talk about plastics, entering our stomachs, such as animals, but we don't know all the threats that plastics can make, such like to our hormones and like to our general health. So unfortunately, we can't give all the answers right now, which is why reducing it before it gets to that point is so important.
Fab. Does anybody else have anything to add? Give me a little wave if you do. Okay, so we've got Sharon.
Like I say, this links into my area of research because there are studies that show plastics have been linked into breast cancer, for example, and that is because of the hormone link. They're hormone mimickers and they change the hormone profile within women, so they can lead to higher levels of breast cancer. That's not to say that everyone's going to get breast cancer. It obviously depends on other factors and smoking and alcohol and everything else. So it's often linking together of all these various factors that leads to higher risk. But there's certainly quite a lot of studies that do show that plastics are linked to certain types of cancer.
Fantastic, thanks Sharon. So there's a bit of a two-part here. It's come through as two questions from the same person, so I'm going to mash it all up into one, and I think I'm going to start the answer to it as well. So if plastic is that bad, why do they make it, and what's something that we can replace plastic with? So part one, why is plastic, if plastic's so bad, why do they make it? The simple answer is it's cheap and it's easy. It's been something that's been made for a really long time. It's really useful. As Nazira said earlier, it's incredibly cheap. So with all of that in mind, why would you want to move to anything else? That's where there are new government incentives like recycling schemes, changing materials, and as people become more interested in the environmental impacts they're making, companies are starting to get a little bit of heat from the general public about changing their practices. So what's something that we can replace plastics with? Well, in terms of us at home, I know there's some things that I've been doing over the last few years. So for example, when my partner goes to work, I used to send them with a plastic spoon to eat their rice or their yogurts with. Whereas now I send them with a little wooden spoon. It's just disposable, made out of like cardboard wood. And that is obviously a lot better than plastics because it's made with a plant material. Things like paper plates rather than plastic ones. Buying, as Elise mentioned earlier, a metal stainless steel bottle rather than buying disposable plastic ones. Things like that. So yeah, that's kind of a two-part answer to those two questions. If anybody else has anything to add, please feel free to say now.
Phoebe, I would just like to add that actually you can now get a lot of good plastic, which is made from plant material, which is then can be broken down and is not harmful. So, you know, not all plastic is harmful to the planet. We just got to look out for the good plastic, the green plastic.
Yes, definitely. As I mentioned earlier, it's not about getting rid of it entirely, it's about making it better. But that's just to answer that question of what can we do to reduce it. So this is the last question now that we've got, because being mindful of the time, we have T-4 minutes before they kick us off. So we've got, if we just eat plants, will we still eat plastics? So I think Elise would be the best person to answer that question.
Thank you. So it's not a case of that if we eat plants would stop eating plastics altogether. That would be incredible, and I think everyone would turn plant-based overnight if that was the case. So the key thing is here that we would definitely reduce the amount of plastics that we eat. For example, like obviously I said that fish were one of the biggest sources, so if you exclude fish, then obviously you're going to exclude a lot of microplastics that you would have been eating. But remember, microplastics are very, very small and they are everywhere. And if they are in the water sources and the water is being used for plants, there is also, of course, a chance that we will still ingest some amounts of plastics, perhaps just eating plants. But it would be a very, very small amount in comparison. So I hope that answered that question a little bit. There is just one question in the chat that wasn't on the Q&A. So I'm just going to quickly go through that while we have the time, as not to make that person miss out. And that is, how do you recycle plastic? So again, referring back to our research section on the website, Making a Difference, there's a little chart there with different types of plastics, and it says if it's recyclable, if it's not, because not all plastics are made equal. And even the ones that are recyclable sometimes don't get recycled because they're contaminated. But generally, when you get a plastic item that is recyclable, you'll put it in your special recyclable bin. It'll get collected by your local council, or if you have a bag, whatever people have these days in their different councils. And that will typically go to a sorting centre, where it'll just get checked to make sure if it is the correct plastic and then lumped in different plastic categories. From there, it'll go into, it can like be melted down or whatnot, and it can be used to make new plastics, or it can be added to what we call virgin plastics to make like for example, let's use Asda's plastic bags as an example. So Asda's Bags for Life, they're made from a combination of recycled plastics and virgin plastics. So they just all go, not all, about 30%, let's be honest, of your recycled plastics actually goes into making brand new plastic items. So I hope that helps everyone.
Fantastic, thank you so much. And that, I think, brings us to the end of our session. So do any of our panelists have any sort of final parting comments before I wrap us up?
I think the only parting comment from me is, you know, making a pledge to remove or reduce the use of all the bad plastics, and let's go green.
Thank you so much.
Yeah, so we hope everyone will get involved in our Dig It Up, Making a Difference project. Hopefully we've made it as inclusive as we can. So if you go onto the website, again, all the equipment is there. If there's something you need to ask, go on our Slido and we can ask that or answer that question throughout the duration of the project. So have fun, everyone, and we hope you really enjoy it.
Okie dokie. So I'm going to wrap us up there. As Elise said, our Slido is on the website. So if you go under Meet the Team, there's a little dark box that says Slido. If you ask a question in there, one of us will be sure to get back to you. So thank you so much to everyone that came along, and a big thank you to the people who asked us wonderful questions. So thank you to Heather, Elise, Nazira and Sharon for getting involved today. We really appreciate you coming. So make sure to get involved in our project, and we will be back on a different Zoom link on the 31st of this month at 4:30 p.m. So thank you so much for coming. Bye everyone.
Bye.